OptiMap.
Alright, so the problem. OSU students waste time and effort traveling to dining halls. There's a real lack of real-time data which forces students into inconvenience, and wasted time costs professional opportunities and academic performance.
The OptiMap can fill the lack of data with dynamic and predictive congestion ratings. It would classify spaces by both people flow and noise level, and the predictive component would forecast future congestion to prevent it before it even happens.
The hardware. We used a Raspberry Pi with a camera and sound sensor connected. The Pi was programmed using Python, and it maps where people are relative to a mapped line. And then using that data, we plus the mic, we track how many people are in the room and how loud it is.
For the server, we used Express.js and had it running on a remote service. Our goal was to provide registered users the ability to retrieve data and for registered cameras to upload data. It involved mainly 2 API calls. It was responsible for directly modifying contents of the database, and it would use middleware to check API tokens.
We used React with TypeScript for the front end. Our goal was just to deliver a user-friendly experience. The dashboard gives users some insights into current and past congestion and noise levels for different buildings. Our goal with the the UI was just to be visually appealing and make it more desirable. And a little pop-up modal displayed timestamps with traffic and noise.
Consistency. Both students and hospitality staff benefit from consistency, which is a significant friction factor. Consistency empowers students to plan their day around inconvenience. Consistency lowers the stress level of hospitality staff during peak hours.
So for trust, a major point of dissatisfaction for students would be the lack of feeling heard. Implementation of this technology can strengthen relations between students and the school, which would help build a culture of trust. And for fatigue, we would be thinking about decision fatigue as a main goal. Optimizing small decisions could free up cognitive load, and we could use quiet areas to reduce frustration and unproductivity.
So we thought of many ideas that we could expand this idea towards in the future, including but not limited to convention centers or auditoriums where we could track the capacity of the building, spread of disease where we could use the traffic modal to gain insight into the spread of pathogens, and a city pedestrian heat map where we could edit a small part of the code in the camera.
What we learned. We learned how to integrate a custom computer-trained model to a Raspberry Pi. We learned how to use a server to retrieve and send data from a database, and we also learned how to directly interface two different types of hardware.